Hey guys, it's Lee's filthy disembodied hands from the future again. Whee! I forgot to mention up front again that there's a shitty Discord server. It's out of control, and I'm part of the problem. But you should come and join the out of control Discord server and lend an air of sanity and class to the place that none of the rest of us have, and civilize we cave creatures that live in the Discord server. There's a thing down there that you can go to and get to it, and there's also, if you'll allow me just a moment to show myself, there's also a subscribe star link, because anything that's worth doing is worth letting people give you money for, if they wanna. I honestly don't give a rat's ass whether I make any money through there or not. The only problem is, if I don't have at least 5 subscribers, I can't withdraw any money for it and use it to buy fun shit to tear apart on video. And I've had a couple of subscribers, and they've been donating money, and it just sits there because I can't withdraw it. So if just three more of you, just for like a couple of months or something, join, just so I can withdraw the stupid money and buy Jove some stuff to make radio videos with that he'll love. That would be absolutely great, or whatever. I guess it doesn't matter. Do whatever you want. Fuck it. I don't want to be a show. All right. Now the video and a filthy finger. Good evening, gentlemen. I know I promised you a radio video, Jove, but not yet. Soon though, soon, don't worry. This is one of those Panasonic floppy drives that was able to read and write Apple II discs correctly on the Greaseweazle, and that's all fine and good, except it only supports it doesn't support flippy disks, you know, like on the Apple II and the Commodore 64 they used single-sided disk drives, so you could get a hole punch and punch out another tab and then flip the disk over and use it, and then it would turn in the opposite direction, you know, and be able to read the other side. And those drives, those systems didn't use the index sensor. That's that little hole right here, there's a hole in the media that this LED right here shines through once per revolution, and then there's a photo transistor on the other side of this shit that sees the light shining up through that hole, and that's how it tells how fast it's moving. And the Apple II and the Commodore 64 didn't use that index hole, but the Greaseweazle does use that index hole, because in order to flux image properly, it has to be able to figure out what the rotational speed of the media is, and it uses the index sensor just for that. That's the only thing it uses it for. But to support flippy disks, we've got to get an index sensor in here somewhere on the other side, so that when you have an upside down disk in the stupid thing, it can figure out what speed it's rotating at. So that's a little bit complicated. I was hoping that normally this spindle motor sits down in here like this, but I was hoping that I could just drill a hole through here and mount another LED here and wire it into power somewhere. These two, this is the right protect LED, I guess. What shines the light for the photo transistor on the other side. I wanted to just drill down through here, but this other screw is going to be right in the frickin' way, so that's not going to work. The way that a lot of the people that modify these drives do it is they'll glue a magnet. Don't lose all my shit here. They'll glue a magnet to this flywheel, and then they'll put a Hall effect switch somewhere, and every time the magnet swings by the Hall effect switch, of course, it will trigger that, and they can use that to, and then you wire that into the index sensor phototransistor on the other side of the disk drive, and it magically works. This flywheel already has magnets inside of it. Let me show you what's going on here. I need to probe this. Everybody likes being probed, right? But I need to probe this thing and see. Oh, jeez. I put those in a little tight. The flywheel has this great big magnet in it, right, and the magnet spins on top of this. Let me zoom in here. It spins on top of this thing here, this coil, we can call it, that's built, that's like etched into the printed circuit board, and I assume that that's going to generate some kind of alternating current that that the disk drive microcontroller is somehow using to monitor the spindle speed and maybe adjust it or something. And if we could tap into that pulse some way and divide it down so it was making one pulse per revolution of the cookie, then that would probably work. Because, I mean, assuming that what the Greaseweazle does is just look for the rising or the falling edge of the index sensor, then it wouldn't matter if it was a pulse or whether it lasted for half of the frickin' revolution of the cookie, right? Maybe. I don't know. Yeah. So, problem is this isn't going to work if I have this off of here to probe at it and shit. So, this is definitely it's a stepper motor here. You can see it's got connections for each of the sets of coils for the stepper motor, I assume. So I guess it just there's three different lines coming in here, and I guess somehow they time that to make the thing spin at a certain speed or something. I don't know. That doesn't seem like it would be a constant speed, but maybe that's why the flywheel's big and heavy. Maybe that keeps it happy. I don't know. Let's mark this a little bit. The coil is these two, and then we've got these three. I'll just draw a straight line through them. And those are presumably the coils on the stepper motor. If that's what it is, this may be something entirely different. I don't know. Maybe it somehow controls the speed of the motor with a voltage level or something like that, and it adjusts that voltage level in reference to how fast it detects that it's spinning. I don't know. Maybe we can probe at it with the scope, and well, by golly, I set that right back on there like it's supposed to be. I had a hell of a time getting it lined up the last time. Well, that was lucky. It didn't have anything to do with skill, that's for fucking sure. Alright, so let me get this thing back together, and we'll see if we can get it back together enough to start probing the stupid thing with a scope. The problem is, though, if we do it this way, see, if we'd have been able to put in another index sensor, when we used a flippy disk, the real index sensor would be automatically disabled because it would the disk, there'd be no hole in the disk there when the disk was upside down, and so it would never trigger. But if we do something else here, we're gonna have to rig up some way to like a switch or something to switch between the real index sensor and this fake index sensor that's just used to determine drive rotational speed. That'll be a little bit of a pain in the ass, but I guess probably not stupidly so. Ah, jeez. So I've got this drive all torn apart. Let me put it back together here enough that we can put a disc in it and start probing it. Yes. Well, gentlemen, I just thought I was recording a whole thing, but my mouse must have double-clicked itself and stopped recording right after I started, because I did a whole thing here and it didn't get caught on the vidgeroo. How very frustrating. That coil that we were looking at underneath of this wheel, alright, it comes out here and jumps through something under here. I think those are just jumper wires, since it's a single-sided board. I should have taken a picture of the other side of the stupid thing before I put it back together, but I was too dumb, so I'm not sure what's down there. Anyway, it jumps over here, and the one of them goes through something up here, and then appears to feed back into the motor somehow. And then, or maybe it just goes to supply voltage or to ground or something like that, I don't know. And then the other side of it jumps over here and then makes a long circuitous path down to this integrated circuit. And it's a really funny integrated circuit. It's got like two great big ground tabs in the center right here, and then a bunch of little pins on either side of that. In fact, if you wish to see it a little better, perhaps I can zoomify here a little bit and get it in the frame for you. Right here, it comes down to this thing. Oh, I bumped something. Oops, I better be careful. I'll fuck something up. I put the disk drive back together wrong the first time, and I thought I'd fucked up the heads maybe, but I hadn't yet. But we're not done yet. There's still time. There's still time to fuck something up. Okay, let me go to the right X turn here, and I'm going to start writing a disk image to the disk that's in the drive just to get the motor spinning. And then we can take our oscilloscope and poke it into the thing in a place and readjust our time base. And we can see here that we've got, well, that's not a good place for that after all. We can see here that we've got, where's my frickin' trigger? Where's my trigger? There's my trigger. We can see here that we've got a 500 hertz sine wave going on here, and it's got some DC offset to it too, which is interesting. But I guess that makes sense. And we can see the same thing on the other side of the coil. Now, if we use like a Schmidt trigger on this or something, we could probably turn it into a pretty good square wave and then divide it down with a series of latches to give us one complete positive high to low transition per rotation of the cookie here, right? But I'm a little bit afraid of loading down that coil thing in there too much by adding something to it, because if we do that, the voltage that it's generating might drop some, and then maybe this chip wouldn't see what it's supposed to, and we'd have some kind of fuckulation going on, and we don't want any fuckulation. Let me start it up again. But if we look down here at this integrated circuit, right? If we poke some of these lines, this is the sine wave that's coming from the motor here. We can see it on there, and if we move up to this other pin, or maybe it was down to this pin, maybe one of these pins has what appears to be, yeah, this one appears to have the same signal with a little bit less DC offset and a higher amplitude. So this IC may be buffering it there. We may be able to hook into that and get our wave to generate our index pulse with. But there's some other interesting shit going on here too. Let's probe some of these thingaroos down here on the other side. Now here's one. This has a quite oops, wrong knob. Oh, it stopped. Hang on. Shit. Someday I'll learn how to use an oscilloscope. It'll be grand. So this one is outputting a pulse, a very short pulse, at 500 hertz. So it's taking the sine wave and turning it into a set of pulses here, but there is still a DC offset to it, which is a little weird. And we could get our signal from there. We could use those pulses and divide them down without having to do as much MIDI trigger stuff. But there's some other interesting shit going on some of these other pins, such as this one here. Oh, pardon me, motor. I slipped. Just our time base here. So here we've got a, what is it, a 25 hertz? Yeah, we've got a 25 hertz, very rough, square-ish wave being generated by this thing. From that 500 hertz signal, you can see it disappears and starts to fall as if there's a capacitor charged somewhere once the motor stops. And I don't remember what speed these things are supposed to run at, but it's possible that this is generating a pulse every... No, it's generating more than one pulse every revolution, I should think. I'm going to look up what speed this is supposed to be, and this signal here, it looks promising to me, and I'm not exactly sure where that's coming from. It's coming from... Oh, that's a signal that's being fed into those coils on the motor. That's interesting. Okay. Huh. Well, if the speed of that signal is based on the speed of the signal that it's, or the frequency, I should say, if I want to be technically smarty pants and shit, if it's being generated based on the frequency that it's coming out of that coil, then surely if we use that to generate our index pulse, it'll be fine, right? I sure hope so. Anyway, once again I spurred out and forgot to eat all evening, so that's it for this time. We'll revisit this project tomorrow if I have time. And I'm going to eat something and go to bed. Alright, bye.